This next section is similar to a section we did, I forget when, but we've done this before. Okay? You guys sit down so everyone can see.
Yeah, Jared.
Okay, if you've got two objects that have either been enlarged or reduced, we'll say this is object A and object B. If they asked you, what's the scale factor
Plus 4. Plus W.
of A to B? What is the scale factor of A to B?
Double. It's 1/2. 2 over 1.
Scale factor of A to B means you take a side of A.
4 to 2.
8. 1 to
4 to
2.
2.
You can either do 4 to 8 or 2 to 4 because they each equal 1/2. So the scale factor of A to B, this is key right here. They tell you what order to do it in. Alright? So the scale factor of A to B is 1/2. That means A is 1/2 of B. If they reversed it, the scale factor of B to A would be 2 to 1. Alright? That means B is 2 times bigger than that. So, the scale factor of A to B equals 1/2. Then, if we found the ratio of the perimeters, okay, the ratio of the perimeters of A to B, to find the perimeter of A, you add up all the sides. 2, 4, 2, 4 is 12. The perimeter of this is 4, 8, 4, 8 is 24. So that is 12 to 24, which is 1/2. So anyone remember doing this before?
Yeah.
What do you know about the ratio of the perimeters and the scale factors?
The same.
They're always the same. Scale factor and perimeters are always the same. Then when we did the ratio of areas, again, they're going to tell us what order to do this in, A to B. This area is 8. This area is 32. So the ratio of the areas is 8 to 32, which is 1/4. Now, do you remember how the ratio of the areas compared to these two?
Multiply by
Areas are always what?
more than
Labeled what? Squared. So the ratio of the areas is going to be whatever these two are squared. Because 1/2 squared is 1 squared is 1, 2 squared is 4. So, if they told you that the scale factor of two objects is 3/5, the ratio of perimeters is also 3/5, and the ratio of areas is 9/25. Because the area, you would just take 3/5 and square it. That means square root of 3, 3 squared is 9, square root of 5, 5 squared is 25. So that's all it is today. Except they're going to involve the hexagons and pentagons and all that. But all it is you find the scale factor, which is just one side to the other side.
Yeah, and
Reduce it.
doesn't matter what sides you pick.
They just got to be corresponding sides.
But it doesn't.
Yep. Yep, I just made that one up.
But since there's like two different like sides, we can pick any one of them
Yep.
as long as it's the same as the one we compare it to.
Yep. So like most of the time, they're just going to give you two corresponding sides. But like Tyra said, if they gave you more, you could choose any two you wanted. They would just have to be corresponding. You could take this and this if you knew it, and this if you knew it. So here they say find the ratio of the unshaded to shaded. So that means I got to take 7 to 21. It reduces to 1/3. So that's the ratio of the perimeters, because it's the same as the scale factor. And then the ratio, again, unshaded to shaded, of the areas then would be, no, 1/9. Because remember, you gotta square it. The ratio of the areas is squared. So square the 1, 1 squared is 1, square the 3, you get 9. So on these two, again, they want unshaded to shaded. Now just to warn you, sometimes they switch the order. They'll put the shaded, unshaded one second, because most people go left to right. So they're just trying to fool you. So make sure you do the one that they say first. In this case, it is left to right, but sometimes they don't. They switch the order of them. So unshaded to shaded would be 12/11ths, or 22/11ths, which you would reduce to 2:1. That's the ratio of perimeters. You can just probably label it P for the ratio of perimeters. And then the areas then would be 4:1. 2 squared over 1 squared. Here again, shaded to unshaded, or unshaded to shaded, is 8 to 10, which we reduce to 4/5. So that's the ratio of the perimeters. So the ratio of the areas, 4 squared is 16, 5 squared is 25. You guys remember doing this before?
Yeah.
Okay, good. Okay, we have a couple problems in our assignment today. I think there's like 4 like this, and then a couple word problems like this, where they just explain the sides. They just don't have a drawing of it. And then there's one like this. You want to carpet a room that measures 40 by 48 feet. An advertisement states the cost of to carpet a room that measures 10 by 12 is $216. So what is a reasonable cost for the larger room? So there's a couple different ways you could do this. You could just draw 2 pictures. Say this one is 40 by 48, and say this one is 10 by 12. So the scale factor is, how much bigger is this one than that? Huh? 4 times bigger, right? So the scale factor, the ratio of the perimeters would be 4:1, correct?
Yes.
Because it's 40 to 10, which reduces to 4:1, or 48 to 12, which reduces by 1. So you wouldn't have to draw a picture, you could just see that. You could go 40 to 10 because they're corresponding, or 48 to 12 because they're corresponding. But we're not talking about perimeter when you put carpeting down, you're talking about what? Area. So the ratio of the area is 16:1. So if this room costs $216, the smaller room, what would you do to figure out what the bigger one would cost? Times 16. You wouldn't use the 4. A lot of people would say, well, this is 4 times bigger, so you take it times 4. You don't. You got to use the area one. So you would just take 216 times 16. And it would be 3,456 dollars. Now, if you actually figured this out the long way, this would be another way to do it. And this is kind of what most people in the real world would do it. They would figure out the area of this is 1,920. Then they'd figure out the area of this is 120. And they would see how many of these would go into that. So what do you do to figure that out? You divide them. And so when you divide them, you would get 16. So I know it would take 16 of these, so you take this times 16. So that's what most people would do it. So, real easy assignment.